What is commutativity? Commutativity, as the name here suggests, it's about commuting the operands. Remember, operands are the numbers in the equation in this particular case. So if you move them around, to commute is to move around, or just to move from one location to another. So commutativity, we're saying if we have x plus 3, and then you commute them around so it becomes 3 plus x, does the answer remain the same? So we see here that if the law is obeyed, then the answer should not change, the value should be the same. Commutativity says if you move the things around and you add them, or you multiply, divide, or subtract, the answer should be exactly the same. Now what we see here is that with addition and subtraction, addition and multiplication, this is the case. If you move things around and then addition, the answer remains the same. So we say that they are commutative, addition and multiplication, because they obey the law of commutativity. Whereas subtraction and division, if you move things around during a subtraction, 3 minus 5 and 5 minus 3 don't give you the same answer. So we see that it is not commutative. Whereas with addition, 3 plus 5 is the same as 5 plus 3. Here are some examples. We are supposed now to show or to prove what I've just stated here when I said addition and multiplication are commutative because they display this property. In other words, they obey this law. Let us check. Prove that addition is commutative. You take those four numbers, 2 and 3 and 4 and 5, and you add them together. You get 14. You take the same four numbers, 2 and 3 and 4 and 5, but you swap them around. You change the order. Regardless of how you swap them around, you see that the answer is always going to be 14. Quod erat demonstrandum. In other words, hence proved. QED, that's what we simply say. So if you try commutativity with subtraction, we find that we use the same four numbers, 2, 3, 4, and 5, and then we keep rotating their positions or alternating, commuting them. In other words, you see that the first one gives us negative 10, but if you move them around, do the same thing, you realize that the answer is now different. It's now negative 8. You move them around, the answer becomes different again, depending on which number is in which position. So we see here that therefore subtraction is not commutative. Multiplication, use the same four numbers. You can use any numbers really. What's important, what we're trying to do basically is just to prove that if you shift them around, the answer will remain the same. If that's the case, we say that that operation is commutative, as is the case with multiplication, and we saw that with addition. They always give you 120 regardless of where you place the numbers. Whereas with division is quite a complicated one, so I decided to just use a very simple one there that you'll easily identify with, where we have 20 divided by 5 is 4, but if you switch the 5 and the 20 around, you get a different answer, 0.25. So in order to prove or to disprove, that's something to disprove anything in science. Maths is a science, by the way. What you simply need to do is to show an instance, a single instance, where the rule is not, where the law is not obeyed. So here, just given two examples, and we see that they give different answers. That's sufficient to say that commutativity is not obeyed here. But when you're trying to prove that it is the case, you may need to use more examples. Even for the subtraction, it would have been okay by just using two examples. If it shows that both of them do not give the same answer, that's all you need to prove. But if you want to prove that it does give the same answer, you should give room for coincidence. So it's possible that it could just be coincidence that they gave the same number, they gave the same answer. That is why you need to use more examples to illustrate. Don't just use two.